Back in 1966, the Soviet Union's Lunar 9 mission pulled off a historic feat. It became the first spacecraft to ever make a soft touchdown on the moon's surface. Before that, our attempts were a bit like playing cosmic shot put. We'd hurl objects at the moon and hope for the best, often resulting in a crash and some data transmission if we were lucky. But here's another mind-blower. In 1959, their Lunar 2 spacecraft was the very first human-made object to smack right into the moon or any celestial body beyond Earth, for that matter. Fast forward to August 2023, and Russia gave it another shot with Lunar 25, aiming for a soft lunar landing. Unfortunately, that mission went south, well, more like crashed into the lunar surface, adding yet another crater and some more space junk to the moon's collection. It's a bit of a head-scratcher, right? You'd think our lunar landing game would have improved by leaps and bounds. Maybe Russia just had a rough day, but hold on, it's not just them. Japan's iSpace also tried in 2023, and they stumbled too. Now Japan is renowned for its top-notch technology and manufacturing, and a few years earlier, India took a swing with Chandrayaan-2, but they missed the mark as well. India's got some seriously smart engineers, so what's going on here? Well, here's the scoop. Landing on the moon ain't a walk in the park. It's like the space race's mysterious, challenging cousin. And here's something you might not have known. The moon's got some seriously wonky gravity. Earth's gravity is pretty uniform all around, but the moon, not so much. Scientists have observed that the moon has stronger gravity in some spots compared to others. It's like a cosmic game of guess the gravity. These supergravity zones often pop up over big impact basins, suggesting that ancient asteroid smashes have stashed excess mass under these craters, messing with the moon's gravitational pull. In 2019, scientists even confirmed the existence of a mysterious mass beneath the moon's south pole. It's estimated to be about 2 quadrillion tons. Yeah, that's a whole lot of possibilities. Sure, it's probably not an ancient alien mothership, but until we get the scoop, it could be anything. More realistically, this mass hangs out beneath the South Pole Aitken Basin, a massive crater on the moon's far side. It formed around 4 billion years ago, courtesy of a colossal impact. The moon's clearly taken some serious hits over its lifetime, scattering these mass clusters all over, and that's why its gravity field is so unpredictable. Imagine a spacecraft passing over one of these. It's like navigating a cosmic roller coaster on the way to a lunar touchdown. When you dive into the history of moon landings, one striking fact emerges. Most attempts have ended in failure. Now, it's not surprising that the early attempts in the late 50s and early 60s had their share of hiccups, but even as NASA kicked off the Surveyor program in 1966, their success rate didn't exactly inspire confidence. Out of 7 Surveyor missions, 1 lost control mid-course and crash-landed on the moon, while another mysteriously lost radio contact with Earth just 2 minutes before attempting a landing. Talk about mysteries in space history. Now let's talk Apollo. When it comes to human moon landings, the Apollo missions were flawless. But here's the catch. It's the human touch that made the difference. You see, people can think on their feet, adapt, and solve problems in the moment, while robots, well, they're not quite there yet, or at least they weren't back in the day. Take Apollo 11, for instance. It would have been a disaster if not for Neil Armstrong's pilot skills. The lunar module was off course from the moment it separated from the main stack, and the computer guidance couldn't handle the unexpected. It was like a spaceship on autopilot, following preset calculations to certain doom. That's when Neil Armstrong had to channel his inner Luke Skywalker and trust his instincts. He landed on the moon manually with just seconds of rocket fuel to spare. But here's the kicker, not every mission has an ace pilot like Armstrong on board to save the day. Robotic missions, like those to the moon, rely on everything going perfectly according to plan. Any deviation and failure becomes the most likely outcome. Now let's talk about the moon's communication hiccup. It's not too far away in the grand scheme of the solar system, but it's distant enough that you can't remotely control a moon lander. The communication delay is around 2.5 seconds for a round-trip message, which isn't nearly precise enough for a successful landing. Now let's flip over to Mars. NASA's had a decent track record of landing there in recent years, even though Mars is much farther away than the Moon. The secret? Mars has a minimal atmosphere, thinner than Earth's, but denser than the Moon's. This tiny atmosphere allows for the use of parachutes to slow down spacecraft during descent, and even airbags for some missions. NASA's larger rovers use a combo of retro rockets and a sky crane. They have the luxury of an atmosphere to work with. But the Moon? It's an atmosphere-free zone, meaning it demands a fully propulsive landing. Even the SpaceX Falcon 9, which makes rocket-powered landings look like a piece of cake, relies heavily on Earth's atmosphere to control its descent. So lunar landers must go from orbital velocity to a standstill on the Moon's surface using nothing but a precisely timed series of rocket burns. It's a major challenge, no matter how advanced your tech is. Let's also give credit for the added difficulty of where these modern lunar missions are trying to land. Back in the day, moon landers followed the path of least resistance. For instance, the very first Lunar 2 impact was pretty much like a ballistic trajectory. The Soviets hurled their probe right at the center of the moon's visible side, and that's where it hit, dead center on the east-west axis and about 30 degrees north of center. Then, when it came to more controlled landings like the Apollo missions, we'd always target an area near the moon's equator on the visible side. This way, the spacecraft would follow a relatively flat, two-dimensional path, launching from the equatorial region of Earth and heading straight to the equatorial region of the Moon and back again. But here's where things get interesting. The Chinese broke this cycle by achieving a soft landing on the far side of the Moon with Chang'e 4 in 2019. However, most recent lunar missions, including the failed iSpace and Lunar 25 landers, have been aiming for the Moon's south pole. Why is this spot so crucial? Because we believe that the deep craters there could hold massive amounts of water ice. And water isn't just for sipping, it's a source of oxygen for breathing and hydrogen for fuel. To add to the complexity, we need to figure out how to insert our spacecraft into a polar orbit around the Moon, requiring a more three-dimensional flight path. But that doesn't make landing at the Moon's south pole impossible. India showed us it can be done with their Chandrayaan-3 mission. The key here is that they had the advantage of learning from their mistakes with Chandrayaan-2. In fact, in most fields, including space exploration, there's no better teacher than failure. It's the ultimate learning experience. NASA's history is a testament to this truth. They had their fair share of lunar landing failures before they perfected their approach. Out of the 9 Project Ranger missions from 1961 to 1965 that attempted a soft landing on the Moon, only the last 3 succeeded. The Surveyor missions had a much better success rate, with 5 out of 7 successfully touching down on the Moon. And once they reached the Apollo missions, all 6 executed flawless landings. Now fast forward 60 years to the 21st century race to the Moon's south pole, and we're seeing the same pattern. Even with all our incredible computer technology and advanced equipment, we sometimes have to stumble before we can succeed. It's all part of the learning process in the ever-challenging world of space exploration. We hope you enjoyed this video of Science with Lou. If you learned something, make sure to hit the like button, subscribe to the channel, and ring the notification bell for more videos like this. See you on the next one.